Okay, let's do chapter 3. Chapter 3 is about the tendencies that your data may have. And again, guys, do your turn part, because it's important that you understand the concepts and you start looking for the way that you learn better. This is a very student-friendly book. It has a lot of examples. It has the U-turn and so on. So, descriptive statistics. We have different types of statistics, and we have the central tendency, in which we're going to cover the mean, the mode, the median. Those are central tendency statistics. We have the variability. Variability tells you how spread your data is. And there is the range, variance, standard deviation. And the other are the relative position, where we are going to cover basically percentiles, quartiles, interquartile range, the box and whisker plot, or the 5 numbers summary graph, and so on. Okay, let's start with the central tendency descriptive statistics. It tells you more or less where is the midpoint on your data. Okay, the mean either for the sample or for the population. We have different formulas. For the sample, the mean is x bar and is equal to summation of x divided by n. For the population, is mu is equal to the summation of x divided by capital N. And that tells you what is the midpoint or the average in your data. The problem with the mean is that if you have outliers or pretty much high values, it's going to be very sensitive to those high values. For example, if I want to know what is the mean of the average of all my students, usually my students are pretty young, okay? So probably the average would be 22, 23 years old. However, what if grandma wants to come back to college, and I have her, and she's 94 years old? When I do the mean, it's going to increase enormously the average of the age of my students. Okay, the mode. The mode is the number that most appear in your data set. You either can have no mode. If I have 1, 2, 4, 7, and 8, I don't have mode. What if I have 1, 2, 4, 4, 7, and 8? I have one mode, that is the 4, because it happens twice. What if I have 1, 2, 4, 4, 7, 8, 8? I have 2 modes, the 4 and the 8. I can have 3 modes or multi-mode. The median. Median is the number that divides your data in half. The median tells you that is a number that really tells you that below that number, at least 50% of your data is below that particular number. And how you calculate that? You first has to order your data in ascending way. Okay, it has to be ascending. And in this case, the median is the 4, because you have 3 to the left and 3 to the right, so the median is 4. What happened if you have 1, 2, 3, 4, 5, 6, 7, you have right here 7. What if you have an even number? Let's say that you don't have the 1, okay? You have 2, 4, 4, 7, and 8. What is the median? The median would be right in here. So how do you calculate that? Well, it's the average of these two numbers. It's the average between the 4 and the 7. Is 5.5. In this case, 5.5 is your average. So 5.5 is your median. And the formula is in the book. So you calculate the I, guys, I is the index. And it is equal to 50 divided by 100 times n, where n is the number of elements in your data sets. If I is integer, then the median is the average of x sub I and x sub I plus 1. So it's this one plus the next one, or it's the average of these two numbers, and that is the median. If I is not an integer, your median is your x sub I when you round up your I. Let's say that I is equal to 3.5. So you're going to round up the 3.5, and it's going to be 4. So your x sub 4 is going to be your median. So it's pretty simple. The shapes, the skewness, either left or right skewness is important, but I'm not going to cover that in these videos. So the skewness gives you how your data is either moving to the right or moving to the left. Okay, so this is negative skewness. This is a positive skewness. Okay, and this is symmetrical. You don't have skewness is equal to 0. Anyways, variability. Let's go to variability measurements. Okay, and again, variability tells you how spread your data is. The first one is range. Range is very easy. It's equal to the highest number in your data set minus the lowest number in your data set. Pretty easy. The variance really depends on the sample or the population. You have different formula for both of them. For the sample, you have s squared is equal to the summation of x minus x bar squared divided by n minus 1. For the population, you have sigma squared is equal to the summation of x minus mu squared divided by n. You can use another formulas that are in the book that probably is easier, such as the summation of x squared minus the summation of x squared divided by n all over n minus 1 or this one is the summation of x squared minus the summation of x squared divided by n all over n. I mean, these formulas are exactly the same, but it gives you different perspective. Okay, this is the variance. What about the standard deviation? For the sample, the standard deviation is s and is equal to the square root of s squared. For the population, the standard deviation is sigma, which is the square root of sigma squared. So it's pretty simple and pretty easy. You have a measurement that is called the coefficient of variation, that is considered the mean and the standard deviation altogether. Okay. We have the z-score. The z-score tells you how far or how many standard deviations away from the mean is a particular number. Okay? So again, z is equal to x minus x bar divided by s for the sample. For the population, the z-score is equal to x minus mu divided by c. And it tells you this number x, how many standard deviations away from the mean is located. And you can tell when we have an outlier is either a very big number or a very low number that are really not representative or not common to your data set. When the z is bigger than 3, positive or negative, then you have an outlier. We have the empirical rule. The empirical rule tells you, and the empirical rule applies only for bell-shaped distributions. Tells you that plus or minus 1 standard deviation, we have the 68% of the data. 2 standard deviations, we have 95% of the data. And plus or minus 3 standard deviations is 99.7% of the data is in this range. And this is the empirical rule. We have also the Chebyshev's rule that tells you, and I mean the Chebyshev's theorem can be applied to any distribution. It really doesn't matter what is the shape of the distribution. And Chebyshev's use the formula 1 minus 1 divided by z squared, where c is greater than 1. So if z is 2, for example, we have that this is c squared is 4. It tells you that 75% of your data is plus or minus 2 standard deviations. It tells you for 3 standard deviations we have 89% of the data, and for 4 standard deviations we have 94% of the data. Okay, and again the Chebyshev's, which I always, Chebyshev's theorem tells you this, and the Chebyshev's can be applied to any distribution. It really doesn't matter what is the shape of the distribution. The empirical rule is used for bell-shaped distributions. Okay, what else? We have relative positions numbers. And we're going to start with percentiles. Percentiles is, and it's called the percentiles are the percentage of value that are below that particular value or that particular number. And that is going to give you by, again, an index. This is not the percentile. This is an index, and you need to have all your data ordered from the lowest to the highest. And the I is going to give you the index of your percentile. I is going to be P, that is your percentiles divided by 100 times N. And again, in this case, it's exactly the same thing as your median. Indeed, your median is your 15th percentile. Okay? If I is integer, then if the percentile is the average of x sub I and x sub I plus 1, and that is your percentile, your pth percentile. And if I is not integer, your percentile is x sub I when you round up your I. Okay? Percentile rank. If you have the set of the data set of your information, and it's already ordered, and you want to know this number, this particular number, what percentile it has. It is a formula. It's the percentile rank, and it's going to be equal to the number of numbers that are below that that particular number, the one that you are interested to know what is the percentile of that number, plus 0.5 divided by the total number of elements times 100. That gives you your percentile. So in your, I don't know if you have seen your SAT score sheet, and it tells you what is your percentile. It tells you probably 82 percentile. What does that mean? It means that 82% of all the people that present the SAT test are below that your score. Okay, that is the definition of the percentiles. That 82 or whatever number it is percent of your data is below your grade. Okay, talking to percentiles, we have to talk about quartiles. Quartiles. We have quartile 1, quartile 2, and quartile 3. The quartile 1 is the 25th percentile. The quartile 2 is the 50th percentile, and the quartile 3 is the 75th percentile. And remember, the 15 percentiles is also called the median. Why? Because by definition is what is the median is, the 50th percentile. And really what the quartiles said is that they divide your data in 4 parts. This is quartile 1, this is quartile 2, this is quartile 3. 20% of the data is below quartile 1, 50% of the data is below quartile 2, and 75, or at least 75 of your data is below quartile 3. And the interquartile range is equal to quartile 3 minus quartile 2. And this number really take away all your data that might have outliers. So it's more concentrated in the 50%, in the what is the 50% of your data in your data. Okay, we have also the 5-number summary graph. And this is called also the box and whisker plot. And it's something like this. Okay? Why it's called the 5-number summary? Because it gives you the lower number, the upper number, and the quartile 1, 2, and 3. So those are the 5 numbers that this graph tells you. This is quartile 1, this is quartile 3, this is quartile 2, this is the max, this is the min. Okay? So, and the interquartile range is Q3 minus Q1, so interquartile range. Now, what happens when we have outliers? How do you identify outliers in the box and whisker plot? Going back to the grandma's example, let's say that grandma's age is 120 years old. So she's going to be like that. Why is an outlier? Okay, you identify outliers by going away 1.5 numbers of the interquartile range beyond the quartile 3 and below quartile 1. And that is, if that number goes beyond that limit, then it's considered a quartile. So the lower limit to be considered an outlier is the quartile 1 minus 1.5 interquartile range, and the upper limit is equal to quartile 3 plus 1.5 times the interquartile range. And that's how you identify your outliers in this box and whisker plot. I think this is the most important part of chapter 3. So that's it. Thank you.